Hold on. Present time. Alright. Is that enough? That's enough. Alright. Okay, second stream. Let me recap from last time. So I got to here. I got to basically the parser. I got the parser retrofitted and the lexer. So I have the parser and lexer here. And this is the main file. So it loops while true. Has error condition, so it sets the error. If not, just redo it again. And keep parsing and parsing with that p-entry file, p-entry function. Yeah, so time between then and now, all I did was bring in the code for the module system. So this is just the module system code. And here, I just call it. So I didn't do much except for standardize everything, bring in some stuff I didn't have with the code stuff, but with the design document, I wrote a whole lot. Specifically here in the compilation strategy. Yeah, so in an imperative language, which is what it was before, the intermediate representation was just simply just a list of instructions. And obviously it can't fly, especially in a language where you can do things like this, like a equals do and then stuff. So this is an expression block, and you can like return stuff from it. So 20. And how do you represent that in the intermediate representation? You can't really. You can't unless you have some kind of like a and then set it and then maintain a list of variables. No, you can't. You can't. So I'm following what Zig does, and allowing you to have this sort of like these like blocks in the AST in the intermediate language. Let's say you have instruction 0 equals do, and then you can have some stuff here, then you can break 0 with a value like 20, and that's how you would implement something like something equals do 20. That's how you would do that. So this is explicit breakout to here. And that's what Zig does. That's what Zig does in the ZIR. So that's what I wanted to end up doing. So I came up with this. NHIR, or nested high-level IR. I think I'll just call it here, HIR. Yeah, so this is more like a lexical structure. So let's say you have A equals this, and then B equals do, and then you also have C equals lambda, which also does this as well. We see DE, yeah. Yeah, D, 20. And it works on the nested lexical structure, so even if there's closures, right? Closures are just functions at the end of the day. Thanks, Anthony. Yeah, closures are just functions. And what you really want is you want to like maintain this lexical structure, which is all ripped away as soon as you go into this like imperative form where it's like all functions are at the top level. And I don't want that because there's things like partial application, yeah, and there's closures as well. So I want to maintain the structure, and what I do, I use this nested IR, which is what Zig uses. Yeah, so closures are nested. The only control, yeah, so how I said before as well, with was it the macro stuff? Where is it? Macros, yeah. Self-hosted control flow, and here predefined control structures. So the only control structures in the language will be do, loop, if, then, and else, and switch. This is for pattern matching. And then you can implement things like for list, so it will be a macro. It'll be like implemented off old stuff. So the only thing you'll ever have is a do to open up a block, and loop to open up a infinite loop, which may or may not return a value. Yeah, so here, the only control structures are the ones that are built in. The rest are created through control macros. So do to open a block, loop to open an infinite loop, which may return a value. They both return values. So don't bother with resolving variables at, yep, to the checker stage, yep. SSA, yeah, here you go. Here, break last instruction, so this I was talking about before. So let's say you have this, v equals do, and then do stuff. What's this? Oh, shit. I owe this guy money. Sorry, bro, not now. Okay. Break last instruction tells you that the last expression was in the block. So let's say you have this, v equals do and do stuff. And then this is the code that will be generated. So 0 is the original value, and that'll get put into v, so store v. Or you can just do v equals 0. That's probably what I'll end up doing. And you open up this block here, so I think I'll make this do. So this is the marker. %1 is the label, so it'll open up a block. 2 is do stuff, it'll load do stuff. 3 is the unit type, it'll load up the unit, and then 4 will call 2 on 3. Then it will break last. So this is the so the break last instruction tells you that the last expression in the block. If the value for %1 is unit, it'll detach and update, showing the value. So this is like the assumed last expression, and if the last expression is a unit type, this the bracket thing, it'll promote it to a breaking with just that. Probably not explaining it a lot. This probably isn't very helpful, but I'm just going through my thought process. Yeah, so checking works like this. Yeah, start at the roots, blah 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 blah. Yeah. Yeah, here, so multiple function calls can have multiple patterns, which means multiple definitions. So this f will generate 3 different defs. And this is my original setup. So I was using 3 different explicit defs in the intermediate representation. But what I really wanted was to merge them all into one. It'll make things a lot easier. So I ended up here, variable think. The line between variable and definition is blurred. Why not merge them like a normal AST? Yeah, like a nested high level expression. Yep, the merging of definitions and instructions will also be present at the top level, and the whole module will be cons propagated as a whole. You cannot share instructions through closure boundaries, only variables. Yeah, so these percent signs don't persist over closure boundaries, only variables. So a closure can rip out a variable from an earlier lexical scope. Yeah, so 0 equals 20, v equals that. Yeah, so this is the above one. V equals 20, k equals that, do. Yeah, so this is the new implementation of 3 different definitions because it's got pen matching. It will turn into this. And this isn't very hard to desugar, not even desugar. I can turn this in a single pass. So this initial def will just be turned into this, right? And what I eventually wanted to do is, let's say I take this, right? This case is this one here. I don't want to make it, like, I want the compiler code and user space code to be exactly the same. So I can just match like this. Case equals tuple of A and B. And then let the checker handle it, let's say, like, the actual signature has different things, like a I32, 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 nothing. So that's 3 arguments, and that's 2. So the checker will pick that up. That's eventually what I want to end up doing. So I can turn all of this code into a single function, and I can turn the lexicalness into something nested. It's like with these this nested IR with do and loop. And that's what I was trying to solve last time. That's what took me so long. I was thinking really fucking hard last time. Yeah, I was thinking hard. I mean, half of that thing was just me sitting there going like thinking. But I spent most of the day just reading and reading and reading and reading source code and writing. So I'm good with this. Yeah, so here, optimization kind, so the high-level intermediate representation. Target of the parser and is checked with semantic analysis, so that's the checker. It's the main intermediate representation throughout the whole compiler, so const propagation. So this is the optimization, so do const propagation, so it'll work with the type system, so for purity and effects, so like the IO. Do expression hoisting, so it'll move things out of loops, that's also useful because of purity. It'll declosurify. That's the thing, declosurify is what I come up with. Since we'll be doing a lot of partial application, which means creating a bunch of closures. Usually when you call a function, it's not going to end up being partially applied. So this is good. Declosurify, that's good here. Yeah, so declosurify. This will also do hoisting, so it'll also move constant things into the closure, which means it won't need to capture any variables. And this one, common subexpression elimination. So this is just SSA stuff. Mem to reg, that's also SSA stuff. This HIR will be like a Swiss Army knife of optimizations. Yeah, and generic strength reduction. Well, strength reduction in the context of a compiler optimization is just... What is it? It's just like, imagine you multiply something, and the equivalent operation would just be a couple bit shifts. That's a strength reduction. But I don't want to implement that here. I want to implement this in the next one. When I say strength reduction, I mean things like probably removing branches, or like, I don't know what I could do here that is generic enough. But in the next thing is the AIR, so assembly IR. So this will do instruction level strength reduction into machine specific operations. So eventually it'll take the whole high level IR, convert it into AIR, assembly IR, and this will be this kind of like canonical form, which will be easily represented in all architectures. And then, so let's say you take your HIR into AIR, and you want to compile it for like x86. It'll run x86 specific optimization. So let's say you have a addition and a multiplication. It would convert that addition and multiplication into probably like an LEA, a load immediate address with the this weird expression. That's what I want it to do, and that's what AIR will eventually do. It'll convert those expressions into that. So it'll be like a machine specific. It'll be machine specific with all the instructions that it supports. Yeah, so this is where I can do instruction level strength reduction. So like I just said, a multiply and an add, or an add or a multiply into an LEA, an x86, and here's CFG, basic block simplification. So HIR is a nested IR, and AIR is with control flow graph. So this is just like graphs and everything. Yeah, so this is register allocation. It'll do register allocation, stacks slot coalescing, so it'll work on live and dead regions. It'll do things like merging stack values into different ones. Let me do some self-promotion real quick. Streaming, compiler development. No, not steaming, streaming. Thanks, Ankid. Hopefully you can get in here. Alright. Alright, I guess I'll start. Wait, let me change my shirt real quick. I'm gonna mute them. Go away. Hold on. Hold on. Hold on. Not there yet. It's fucking hot in here. Yeah. Usually I don't open my skylight, but it's like hot. Wait, no. It's cold. No, it's hot in my room, but it's cold outside. Yeah. Alright, I'll start. Okay, what I need to do is get the old... So I have different syntax. So let me get rid of this. Let me change all this. So I use an X macro here. So I don't need function, don't need ASM, don't need as, don't need return, don't need let, don't need mut. I need if. I don't need any of these yet though. I think the only... What's the only keyword I really need? IO and do. IO, do, and loop. Okay, I'll do that. Okay, do, loop, talk, do, talk, loop, talk, IO. IO is important. I don't really have any keywords right now. Okay, inc, assign, add, deck, sub, assign, div. This is usually a pain in the ass to set up. I have like a macro system here. I have like this thing. Define X, and this is just this big macro list that gets expanded into all of the matching things. Yeah, talk div, talk assign, talk mul, talk eq. That's all of these things I want to keep. Maybe make this pipe. Okay, I don't know why that's separate. Okay, just delete that. I don't need Zor. RU shift. Yeah, these are good. 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 I don't need braces. There's no braces in this programming language. Colons needed. Questions needed. I'll deal with these later. Talk is infix. Where is this used? Okay, well, it's used somewhere. I'll get errors later. I'll deal with it later. Okay. Well, I'll start by doing top-level declarations. First I need to... That was easy, what I just did. I just changed a couple keywords. What I need to do now is sketch out the entire intermediate representation, which means you start from functions. Oh, I should have done this before I got here. Okay. That's my fault. I'll do it in here. So you need a module. The module holds everything. It needs like a declaration. What is it at the end of the day? It's a bunch of declarations. Oh, I fucking hate capital. Alright, you know what? Before I get to this, I'll just do the parser. Yeah, p top. So, oh yeah, here. This is what I prototype. Well, no, I didn't prototype. This is what I used to test. Here. So I run the file, and all it does is loops and loops and loops. Does a printf, and gets the current input. Checks for errors, and then runs the pentry file. And all I have here is it does pnext to do talk, and the talk peak. That just initializes some things. And then while the current token is not EOF, expect that the current token is talk identifier. So you can write hello, hello, and that's fine, hello, 2, and it raises an error here. error, standard in 1 to 7, unexpected 2, expected identifier. And I'll just like do that. Yeah, 1 to 7, expected identifier. And that's really good about having old code, because writing that was a pain, and I'm glad I did that 2 months ago, 3 months ago, 5 months ago. 5 months ago. Alright, let's start. Top statement. Redefinition. Where? Okay. Yeah, so it has all this stuff. Tuck import, function, pub, const, top level const. Alright, well, I'll implement... Ah, this is gonna work. This is gonna work really differently. Okay. No, I can't even start yet. I need to go start sketching out the IO then. What is it? Unit? It's a scope, right? Right here? I don't right here. IR node. This is a node. So it'll be comprised of nodes. Let me write what's the API? Do API here. Strategy IR is what I want. Yep, alright. What am I gonna write? API. So the enclosing thing is a IR node T, which will enclose over all of these. It'll close... I want to merge definitions. Huh. I want to merge... Yeah, so this is my biggest issue right now. Instructions, like an instruction is about 16 bytes. Here, inst t. Yeah. So, okay, this seems big, but it's a big union. I think, yeah, size 64 bytes. So, okay, that's big. A PIR instruction is 64 bytes, which is big, but relatively big, relatively small. And I want to introduce an instruction in like a def t, and which would be huge, right? Because it's a function definition. Or not. I mean, 64 bytes is a lot. These are all 4 bytes. And that's huge as well. That's huge as well. That's huge. Okay, you know what? Fuck it. I can merge them. I'll merge them. Alright, so the whole thing is an IO node T. Would it be equivalent to a do? IR... You know what? IR do. T. But it wouldn't be called a do. It would be called a scope. An IR scope. IR scope T contains a bunch of instructions. IR inst T. A bunch of instructions. IR IT. Is IR op? Okay, IR inst. Instant good. So it's a scope contains a bunch of IR ints, which could be a like function decls. Oh, this is gonna get really big. If there's 64 bytes per instruction. Anyway, function declarations. What else? I can do space savings later. Function decls, expressions, etc. It'll chain more IR scope T. Alright, well I can just do this. I can do this way. Struct IR node T. Duplicate that. And I'll make top level scope separate. Top level scope T is separate, even maybe different. In different data type. Entirely. Yeah, I want to make that separate. Here inst t. Now it says kind. I had that up here, didn't I? I hope not. So that'd be stupid. I didn't. Okay. Enum ir I kind t. Yeah, that seems nicer. What is it? What's in it? What's in it? Inst. Do it inst decal. Fun decal. Oh, proc decal. I'm not writing a fun decal. Yeah, so a nup. Good nup. All right. Yeah, so inst nup, inst proc decal. What else? Load, store, literal, add of, cool. Okay, no side cool. That's all I want to really implement today. Integer literal, sure. Yeah, inst. Yeah, next, previous. This is gonna suck. I'm only doing const propagation. Yeah, I'm gonna need this. Yeah, ID. I'm gonna rename this type def idx. IR node too. That's probably the easiest way. It's IRR inst. Yeah, but this is not a node. This is supposed to go inside IR inst t. Yep, and then all this is gonna go in here. R inst t. Yep, unknown type name. Structs. Duplicate that IR node t. Wait, no what? No. U32. I already have a duplicate of that. What am I doing? Inst t. Alright, so the node contains an icons, ID, next, previous. What else? Location. I might want to define to do define helper function for invalid. Function for invalid lock t. Okay. What are we doing for time? 30 minutes. That's not bad. Alright, type T. Let's type. Alright, no container union. And then IR node is... It's... All the instructions are going to steal from a big pool of nodes. Anyway. Okay, sure. And just make this a static buffer. Then the pointers will stay stable. At the end of the day, I think I wrote about this. I'm gonna write a piece of shit compiler in C. It's a piece of shit. It's gonna work though. And when it works, I write the bootstrap compiler, and then I'll be done. I'll be done with it. I won't have to work in C anymore. That's the last thing I want to do. Write C, even though I love it. It's not good for a big project. That's why write the bootstrap compiler as quickly as possible and as shittily as possible. And then you're done. So just write an extern ir inst array. No, ir inst arena. In 24. We'll make it even bigger than that. 2048. Sure. And then I don't know why it has to be here. I'm pretty sure we can just put this in ir.c. And I'll do that later. Okay. And the node t just contains a start and end. There are inst t. Okay, thanks, Copilot. First, last. Should this be a scope or node? Talking to myself. Scope t. I think this should be a scope t. And then, where did I write? Scope something. No, I wrote it somewhere else in functions. Yeah. No, I wrote it in roots. No, I wrote it here. Then where did I write it? Syntax? No. Did I write scope? Okay, well, wrong point. Where did I put it? Okay, forget it. I remember what I wrote. Scope kind. Is this gonna be a chain? Am I gonna arena allocate them? Sure, I will. So this will just be a chain. TIR node arena. Alright. Enum IR S kinds T. It could be either scope. Just scope. What else? I want scope. Scope loop. Scope do. No. No, these are all the same. There's no difference. Okay. That's a good thing about this. What do they write? Scopes. Parser. Scope. Oh, parser scope. Yep, it has a break and predicate. Inst. What's it? Basic block. It's self. Label self. Label pred. So I would go continue here. Break here. So that's the predicate and it's itself. Is it not predicate? Predecessor. It's predecessor. That's what it was called. Yes, everything will be expression based. Yeah, it's not very imperative. Alright, well, let me copy the stuff that I did for this. PIRT. This is some, like, stupidly annoying linked list stuff that took me a long time to do. So, I hate linked lists, so I'm just gonna copy this. And rename all of this to a IR inst t. Proc t is one of them. No, that's different. Yeah, no need for proc. This is basic block. BB ref. Why does that need to be known? Ah, okay. Basic blocks are basically scopes. Yeah. Alright, so I just need U32 len. These are scopes. These are basically nested lexical basic blocks. That's basically it. That's yeah, so which means I need an R inst and I need an R scope. Include all.h. Change R blocks to what is it? No, R scope T. I don't it was BB ref. Scope ref. Rename this R inst. Why did that fuck everything up? Alright, R push as well. That's important. Need STB. STB. Yeah, STBDS. Okay. No procs. Yeah, okay, so I'm gonna use a static buffer anyway. Yep. Node P. Why is that? Does it not have a def? Oh, it's scope. Scope arena. That's just the arena. What's the Genesis arena? Well, no, what's the original one? There's gonna be yeah. So there is a distinction. There is no distinction. I mean, between top level and not. Which is I'm gonna write here. Distinction? No, there's no distinction. They're the same. Yep. I did to ir inst arena len equals 0. We already know it's 0. Scope arena len. We'll let the address sanitizer catch this. I don't really care what it is. Inst len. Just find all of these. Replace them. PIR at. Okay, R push is just the equivalent of IR inst arena. IR inst arena len plus plus equals inst. That's the equivalent. PIR block. Okay. And this is the equivalent of yeah, this is the equivalent of inst arena. Scope arena. Yeah, turning into a scope t pointer. Rename basic block to S. Sure. Yeah, rename that to S. BB. Yep, rename this to S. Okay, IR inst T at int. Okay, PIR at. Let me just rename. Make this a macro. No. PIR at is the equivalent of what in the instruction? Yeah, so it's just IR inst arena at. Yep. That's its equivalent. Rock at. Make this rev. inst prep. Done. All right, now you have. Why am I saying all right? I'm saying it too much. I watched the old VOD. I keep saying it a lot. Yeah, so now I have insert after, insert before, and then yeah. So this is all this linked list stuff. And then what else I would need is I don't want to name this PIR, just IR. Yeah, IR insert. These do IR appends and then IR prepends. That's a lot easier. Yeah, so yeah. Alright, let's do the parser properly now. Which means I need to create nodes as well. IR. Oh, let's name this. IR scope T, IR scope. This will just return a scope, so it takes a void. I'll let Copilot fill that in for me. No, it's just an ID. No, I'll just return a pointer. It has to be a pointer. Thank you. First and last, len equals 0, return s. That's exactly what I wanted. And it takes in a scope ref, which can be grabbed from the ID. S has an ID. It doesn't have an ID. Could have an ID. IR scope T ID. ID. Okay, fill that in for me. Scope ID. I don't want to do this negative one stuff. Good. Alright, p top statement should be equivalent to anything. I think it should just be p expression. P expr. No, because definitions aren't expressions. P statement. It's p statement. There's no definition. There's no difference between top and bottom statements. Except for when you're doing data types. Fine. Okay, I'll do a top statement. Okay. Let's just make it a big switch. Switch. Token. Talk. Stop kind. Okay. Defaults equals void estimate equals void piece estimate break. Yep, and then just throw this in here as well. Alright, and then p expr void p expr void do nothing. At midnight? I have no idea. Wow. That's nice. Thanks, Anka. You're even here. Alright. Show me the chat. Alright. P expo. P statement, P top statement. Alright, well let's start. Oh. Yeah, alright. Okay. Context-free parsing. So you know it's a sign. You know it's a declaration when it's always a just this v equals something. If it's at the bottom, because in this language there's no difference between assignments and equals. The only way there's a difference, like the only way the compiler can tell the difference is because there's no variable shadowing. So you can have v equals this, and this is an error, right? You can't redefine it. It's first like known. Its first known viewing of that variable is its definition or declaration, and it can't be redefined. You can't shadow variables in this. So it knows this is a assignments. Yeah. And then it also knows, this is a function declaration. So this. All right. So I'll match function declarations first. Case talk. There. Case. Yep. And if token kind equals talk ident and the peak token talk colon. Yeah, is another function declaration. Kind. So these are the different kinds of function declarations. There's an IO name. Autocomplete for me. No, okay, auto name pattern equals. No, there's no pattern in an IO declaration. Or is there? Yeah, here, IO this equals this. This defines an IO operation. Pattern. Okay. And this equals this. Let me just align these. Yep. Name equals pattern. So these are all the times you'll actually find a function declaration. So it would be talk ident. Yeah, void p function. P proc. It's a cooler name. P proc. Call that here and call that here. This is a function declaration. No, I don't want an abort. No, don't tell me. Built-in abort. I'm too lazy to import it. Alright, pproc. How did I do this before? Alright, bool is IO equals false. Yeah. Token. If p.token.kind equals talk IO. Yeah, thanks. If okay, no, it needs to expect p.pcheck. Where's pcheck? Down here. It's at the top. Yeah. No. No, you. Oh my god, I swear. Did it. Fuck that. VS Code sucks. Just die already. I can't even undo. I can't even undo. I need to bring the code from... It's a timeline, right? The timeline. 3 seconds ago. Just take all the lines. No. We deleted lines. I'm glad it's got that, at least. Alright. P check, which means check the current for a talk ident. Alright, so it specs identifier. Name, and then yeah, this is what it's the naming convention used to do. Lock t, name lock equals. Okay. Parser function. Oh wow, this is what I did for all of that. Yeah, so I'll get. What are we doing for time? An hour, coming up to an hour. So I'll do function declarations and parsing types. Yeah, I'll do that. Yep, so p top statement. So yeah, these all have to take in. Okay, p top statement doesn't have to take in a specific scope, but statement does. So no scope stack. Doesn't need that. P R scope. P scope T. Oh yeah, I already did stuff here. Okay. I can get rid of all of that. P-val I keep. P-val I keep. But the scope stuff, that was from last, I think, yeah, I did that last time. I don't need P import. I can do P import later. Scope kind, all this up to P-val. Don't need. P import. Can go up here. Yep. And then a P scope T. Root. PR scope. No. R scope? R scope T. Okay, then what is scope T? Okay, don't need that. PS kind, don't need that. Don't need any of these. Eval, separate, import, don't need import. I'll do this all later. Eventually you'll come to see what they're used for. Man, it shouldn't be a pointer. Just be root. Used top level. Using top level contacts. Alright, so when you create the entry. P context P. You'd want to save the root. The root is always 0. The root's always 0. Inst arena len equals 1. Root is always define scope root is 1. Now put that definition in all. No, not 1. It'd be 0. It's my fault. Alright, and then what you would pass to P statement, because R scope T is S scope. And what you would pass is scope root, and that's the root. Alright, P procs in here. Oh, no, it's in here. So S. S. Okay, it takes an S. S. Expression takes an S. Good. Yeah, so P statement is scope root. I won't do patterns. Yeah, I'll do a void P pattern. I don't think it requires a scope. But it does require to figure out external representation of a pattern map. Yeah, so this will just be called later on. Yeah, so when you get to here, you'd be IO name. You'd be here. Yep, and then do P next. So the next one. And what comes next? Comes next is this. Token.kind. Zip colon. P next. And then just sudo parse pattern. Alright, expect the sign. It'll expect it anyway. Expect a sign, and then it would call expr with S, and then that's a to-do. And then I'll just do a printf. Perfect. Let's see if that pauses. Right, just write scope D. S. Alright, I'll try it. IO name equals. Good, that pauses. Name equals this. IoT instruction call dumped. Where? What? Where does that come from? Alright, GDB it. Continue. No. Run. Name. Sig aborted from where? PXpr? Oh, PXpr is being called. What? No, it's not. Oh, that's being called. I don't know. Then what token is that? Tuck dbg stir. Okay. P dot token kinds. V. No. V. Enter. Sure. EOF. What? That's not real. Oh my god. So I'm not returning. Alright, A equals this. Alright, scope IOA equals. Great. So we have that done. That's 59 minutes. Time to parse types. So types in this language is like Haskell. It'll be done like this. Let's say you have A is whatever, and then you want to define its type, so it'll be A. So this will just be your void. B will be an I32, returning an I32. So that means you do like a B. V equals B plus 10. So this takes in an I32, returns an I32 plus 10. That's how it works. So it uses the double colon keyword. Not keyword, it's a token. Yeah, alright, let's get that token in then. Colon. this is double colon. And I'll wait for that. Alright. Case. Yeah. I don't want to. You know, fuck it. I don't need to nest them. I can just do fall through. Isn't that just a more elegant method? Idents. Just do fall through. If he rock s break. And just do fall through. If p.peak.kind equals tuck. What is it? Colon double colon. So this is a. That's a function definition, and this is a type int. He. What is it? What is it called? This thing. Type equals. I don't know what that's called. It's called like not a type assertion. It's what you put, like the type hint. I don't know. P type def. No, that's different. P type decal. Or P type decal. I don't think it requires an S though. It does. It'll be inserted into the code. All right. Top. The all words. Let's see, precede should be before the decal of a before the init of a value. All of this should be before the init of a value if it ends here. Error something because this is malformed. That's a genuine statement, so it's not an expression. Yep. Types values with unknown types will reference. No, a will have explicit. The checker will find this. The same way akin to the pattern. Let me fix the camera, because the camera's not pointing at me. What the fuck? Akin to the pattern matching slash defs. Yeah, multiple defs. That's eventually that's what I'm gonna do. So peep type decal. Yeah. Yep. Yeah, it already knows, so just pnext, pnext. Assumptions. V equals I32, I32. And we are right here. Bring back the parse type. I need to bring back the type table. This is a table and then types. I need to bring back types. Okay, let's see how many errors we have. A lot of fucking errors. Typeinfo T. Alright. No. This is something I can probably take. Type concrete max. No, I'm not doing whatever that is. Okay. Concrete literals list. So I8, I16, I32, I64, I size, U8, U16. Do I like U size or U int? I'm keeping that. And there's no type, no return. Okay, well type no return is, well the bottom type is this. Make this a Y. Talk. Exclamation mark. Be not. Is there an exclamation mark? Here's this. Talk not. Thank you. I'm taking that. No, this needs to be explicit. Type of void. Why is that separate? Void isn't a keyword. But it is. Yeah, I don't know what I was smoking when I was writing this. Types. Type X. Yeah. Type concrete max. Type concrete max equals the value of the last one. Yeah, anyway. Type unknown. Yeah, what is that? Reference to be filled in later. That's what it's supposed to be called. Okay, tuple, function, and pointer. We'll just do tuples for now. Type units is an empty tuple. Type bottom. Here. Type unit is this. Type bottom is that. And tuple can go here. Well, a concrete type is... A concrete type are these. Yeah, alright. Maybe I was right. No, why do these have names though? I don't know why these have names. Okay. Too few arguments. Okay. Type void. No, type units. Type bottom. Type. Okay, those are the two built-in ones so far. Wow, you can't even put comments. Yeah, alright. Type unit and type bottom. Alright, here's this type info. No. TI kinds. These names are long. T info. Type I kind. T info. Yeah, this seems right. Tuple is a type T of LMs, elements. Function. Yeah, a function type, in this thing is like its curried representation. So all this is just a type. Type T. Yeah, it's not even a return. Well, it has a return. So it's just take arg. It only takes an argument and a return. Curried curried representation. Why does it have a name? It shouldn't have a name. Type a ref. Oh, this is for other things. Struct. D named. Which means this has to go here. And name types like aliases. Right, this seems good. This seems good enough. Can bring this in here. And I'm gonna fix all of this. Oh. Hold on. I fucking kicked the thing. Hold on. Come on. Alright, you can keep going. Nothing happened. Tinfo. Types. Type len. Don't need this. Tinfo. TI kind. typeinfo t. Okay, that's the dumbest name. It should be ti kinds, not. No, ti kind. Denamed. It should be denamed. 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 Type pattern, type function. Type function. There's no args len. Just do if argument equals b. Argument return false. No, it wasn't equal. Rats, and then let's return true. Oh, cert not reached. I don't have that yet. Cert not reached. Yeah, this is my favorite. Yeah, I want this to always show up regardless. Alright, compare typeinfo works. FS module SV. Yep, that's useful to me. So I'm gonna export that. Where's FS? Where do I store the FS stuff? Yeah. Typeinfo.module. If typeinfo kind is not unknown, therefore nb.kind is not type unknown and is already defined. I don't believe that. I'm pretty sure I gave this rigorous, not even rigorous testing. I think I gave it well thought out testing. Okay, I just assume this is okay. Okay, it's alright. Type pointer. Incmul. I don't have pointers. Not yet, at least. A CT info stir. Oh yeah. Static consts. Pointer. Is that right? Huh. Why do they need all of that for them? Yeah, I'm using X macro to declare all the typeinfo stuff. No. This one. Literal type. Now, does that work? It works. I don't know why I didn't do that though. Anyway, this is how I get all the literal representations. Names. Denamed. Pointer isn't real. Not yet. Okay, function type. It's right associative. No, it's fine. Okay. How did I do it? Type function dot argument. Type function dot rats. And then I want to commit the string to the return buffer. Perfect. And then just return. Good. No more errors left. That seems fine. And I want to export this. Alright, how do I, is it parsing? Parse type? What am I doing for time? Okay, 1 hour 30. Parser get type. Okay, parser parse type. Okay, this isn't that long. Alright, key type. Which would take, it wouldn't take in a scope because it's not needed. But it will return a type to you. It'll return a type T and return return type T and accept void. Unknown module. Oh, that makes sense. Cannot contain void type and tuple. No, but we're allowed to have these. Alright. Neutral parse. I was needed for that. P.talk.type. No, P.talk.kind. Case. Talk. Ident. No, there's no need for that. I'm not going to do that. I'll implement this later. Implement it now. So maybe we do need this. That's funny. Yeah, I've never seen anyone have externs not at the top level. But I don't really care, so I'm just gonna do that. So. Yeah, type X concrete literals list. Yeah, this will just put, it'll convert all the strings present in here into string views, like intern string views. So all I need to do is a single integer comparison, which is great. Parser get type. Yep, 4. No, thanks, ChatGPT. Yep, thank you. No, just do. Set not reached. Alright, case, ident. It's fucking late. It's a 1. Don't worry. I'll be fine. Okay. Let's next. No. set not reached, else type equals p get type. P type ID from identifier. Get the current type from identifier, which doesn't take in a module because I don't need that. It takes in the literal, which is initial. Mod. Yeah, this is for module system. So if you have a something like this, ident dot something, it'll take it from the imported module, and I can do that later. Terminating condition break. And I'll copy this comment. Yep, case talk opar is tuple. I'm just gonna take all of this. Parser parse type. Parser parse type. It's p type. R push. Yeah. What's parser? Do I not have parser unexpected? Void. Is it no return? Where is it? Where's the definition of this? There's no definition of this. Wow, why is it in lexer? The unexpected. Sure. P unexpected. There we go. And then our imports include stbds. Just so I can get dynamic arrays, because I'll need it here. I'll push. Yep. How does this even work? Let me read the code. Talk is not cpar. Class type. It's just you are currently here. After this, single. Yep, this is an optimization to avoid allocations. P token dot kind equals talk dot comma next. Parse equals false. Is that right? Oh, nice optimization. Return type units. Now, what do you mean? Sure. Type equals type new. You don't even have type new yet. Oh, some type. Yep, and I want to make location optional, so I'll make that a pointer. Type tuple. What's the location? LMs. Initial pause. No, wait, no. It's not named. Wait, then why do I need location? Ah, it's already defined. Alright. Okay, kind equals tuple. It's not named at all. D tuple equals. Yeah. So I want to do an optimization for the tuple type. Yeah, tuple. So lms and len. If len equals 1, then lems. You would want to coerce that to a type t lms. Is your type? Sure. Type t equals payload equals lms. If no, there is no single. It's just the type. Am I fucking stupid? No, yeah. Alright, fine. lms d tuple. Well. Yeah, this is a terminating condition. It's also a terminating condition. He unexpected. Type in definition. And then return type. Perfect. Oh, I want to parse functions as well. Do I have enough time? Oh, I'll be going over so much time, but it's fine. And I want to print that as well. Type dbg stir type. No. There we go. Yeah, so I'm gonna print this. Print type parsed equals yes. It's just that. Too many arguments. No, it needs S. Because it's... Oh yeah, S. It needs it because it's an IR. T equals, I think, 2. Oh wait, break. Oh yeah, it's all about the order these things appear in. Let's go above. Type pass, I32. Done. Well, not yet, not yet. Let's do a tuple. Wow. I32. Type pass I32. T equals unit. Type pass equals null. Is that not right? Why is it null? Do I not handle everything? Oh. Where do I use this? Literals. No, I don't use that when I convert. Commit sprintf. Why is it null? Wow, it doesn't even get here. Type unknown. Type unknown. No. Type unit and type bottom. So is that right? That's why. That's fucking why. Good. Oh yeah, exclamation mark for bottom type. I don't know why you would ever need to use the bottom type. Because it's always an error to evaluate it, not an error. It's just when you evaluate it, something happens. Yeah, p-type. Case, tuck, not. P next. Type equals tuck bottom. No, type bottom. No. Break. This is terminating. Perfect. So that pauses. That works fine. Alright, let's pause functions now. Fuck, it's 2 hours. Yeah, we'll pause functions. It's not a bad idea. Talk arrow. This is like a hackrat parser, or a no, it's not that. This is a precedence climbing parser essentially. This gets the left hand side, and this gets the right hand side. Yeah, this is how it works. I32, I32, I32. Then essentially parses down. This is the curried form, so the curried form turns into that. So a precedence climber with only one operation, which is the is our Alright, if p.peak token equals kinds equals talk arrow, that means recurse. How do these work normally? I don't want to introduce lots of recursion. I don't want to introduce lots of recursion, so let me go to the parser. Expr. It takes the left hand side and then return while I'm just gonna recurse. I'm not bothered. To do currently a recursive and should be using while not type fn to make it work basic an expression. All right. No, it's not p.peak, it's literally the current token. Right. Yep, we're basically here, and then parse the rest, so p next. And type is p type. It's not arg, it's args. I don't know what the name is. Yeah, arg and rat. That's what I would name. Yeah, that's what I would name them. Yeah, parse curried form. Sure. This is left right associative. Just remember argument. It's just arg. Oh, even here. Arg. Right. V is a function that takes an i32 and returns an i32. Okay. V is a function that takes an i32, returns a tuple of two i32s. Okay. V is a function that takes an i32. Yeah, V is takes an i32 and returns a that. V takes an i32, 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 i32. 1, 2, 1, 2, 1, 2, 1, 2. Wow. Okay, well, I guess I'm done. What do I have so far? Let me do a git ignore. Git init, gets code. Let's see. Alright. Gets commit message. programming language compiler to implement init number 2. Finally commit some code. No git reset. No git config. I don't use this old one. Init number 2. Finally make some. Finally commit some files. Done. Let me pause the music so I can actually think. I've been thinking this whole time. Let me undo this. Alright, what did I do so far? I implemented REPL, type parsing, function parsing. Yeah. I'll go over how the type system works. Basically, you can create types, and this type is the typeinfo, so it has the whole thing about the types. Anything that is a concrete type, like I8, I16, all these things, there's an optimization that just makes them just integers. But if it's something larger, like a function, it'll have to index into the larger types array here, which will return a typeinfo, which describes the type. So anything below underscore type concrete max will make it a concrete type. Anything above will make it something different, like a tuple, function, array. I don't think array. Yeah, array. But all these other things will be separate. So I think that's it. Yeah, so compare type info. Yeah, so all the types will be interned. What is it? Interns. They're there's no all types are unique, and they all come off each other. I'll show I'll show an example. What did I do here? I'll show an example. Just for the people watching. If there's anyone watch this far. Where is it? Table dump. I'm pretty sure I have it already. Where's table dump? Oh. Okay, where's type dump? Alright, void table types dump then. For I32. Yep, just complete the rest. Thank you. Thank you. This will help you understand how this works. Right, v I32. Oh wait, what? Type parsed I32. Types done. Is that right? Oh yeah, no, because there's no custom types. But when there is custom types, there'd be this. So what is it? Type 15? Yeah, an integer 15. There's gonna be a specific type in I32. But let's say you have a I32, which was an I32. Assert not reached. Oh my fucking god. Okay, fine. Case type tuple. No. Oops. Alright, thank you. V is an I32, which means that this gets inserted inside the type table because it's a type it hasn't seen before. And V I32, it's an I32. And this is a new type it hasn't seen before. So this type 16, actually references type 15 here. It doesn't actually duplicate it. So all the types get interned throughout the whole execution, which saves a lot of space. I think that's it. That's it. I'm gonna close everything. Go to here. So REPL types and functions is what I did today. I did all of this. Did all of that. I think I'll be more productive if I do streams in the morning. Like, I need to do streams in the morning. I need to do all of this, write more in the morning, do more off camera. I didn't do enough off camera. I did some off camera today. Other than that, I think that's done. I'm done. I'm done. It's late. No more. Closing. I'm gonna close this all done.